Welcome to the very first lesson in geometry. We're going to be defining a lot of vocabulary today and talking in some detail about notation, or the way we write things so that other people understand what we're trying to communicate. It's really important that we're careful with our notation. If you're wearing a blue shirt and yet you keep talking about the lovely red shirt you're wearing today, people are looking at you funny because what you're wearing doesn't match what you're talking about. That's what I mean by notation. What we write has to match what we're talking about, or the person who's reading our work doesn't understand. Our essential question today is, how do I identify and notate basic geometric structures? All right, now any vocabulary that I highlight, you should make a flashcard for. The word on one side, the definition on the back. You need to be studying your flashcards for 5 minutes a day. Okay, and you need to study all of the flashcards as we learn them throughout the year. In other words, cumulatively, because there are over 1,000 vocabulary words, theorems, and postulates that you have to learn in this class. If you don't focus heavily on the vocabulary, this class is going to be a disaster. A point is the most basic structure in geometry. Here we go with the highlighter. Okay, a point is a specific location. It has no width or length. In fact, it has no dimension. Now let's stop and think about that for a second. No dimension. It's invisible, technically. It's just a spot. There's no width, there's no length, there's no depth. It's got nothing. We always use a capital letter. Now we draw it with a filled in dot and we name it with a capital letter. And our drawing looks like it has width and length, but that's the limitations of having to draw something that's technically invisible. Okay, so there's the difference between what it looks like in a diagram and what it is mathematically, and that's really important. Our next structure is a line, and lines are made up of points. Lines have no width and no depth, but they do have length. They are one-dimensional, and that dimension is length. You name lines with any 2 points on the line or with a lowercase cursive letter. Let me highlight this one. Okay, so let's do a couple examples here. Okay, there's my lowercase q. I could name this as line AB, capital A, capital B, with a little baby line symbol on top. That symbol is super important. When we look at this, we actually read it with the symbol first, line AB. So what's on top gets read first. You could also name it line BA, or you could spell out the word line and use the lowercase cursive q I labeled it with. So you have 3 options for naming this line. Okay. Collinear points are points that are on the same line. So in the example I drew up here, points A and B are collinear. Non-collinear points are points that are not on the same line. So if I added in a point C, points A and C are non-collinear points. Take a look at the word collinear. Co is an English prefix meaning to or with. Linear means line. So on the same line or together on the same line. Non is a prefix meaning not. Okay, more important vocabulary to know. Let's talk briefly about parallel lines. Parallel lines use a symbol of the two little lowercase l's. Okay, and on a diagram, we would use a caret on the parallel lines. That caret needs to be going the same direction. So if I named this line L and this one line M, I could say line L is parallel to line M. Now, if I had more than one set of parallel lines, you use more than one caret. So this one, and then a double caret. You can do triple carets, quadruple carets. Technically, there's no limit to how many carets, but the reality is, once you get past triple carets, it is so hard to read. So please break out the colors. All right, a single caret in blue would be different than a single caret in red. Perpendicular lines. Perpendicular lines use the upside down capital T, and they use a right angle symbol. Coming down here to the diagram, that's the little box that you see in the diagram. It's a little baby square. Stop and think about that. Perpendicular lines meet at 90-degree angles, and squares have 90-degree angles, so we put a little baby square in there. I could say segment TS is perpendicular to line D. Our next vocabulary word is ray. A ray is part of a line. Rays start at an initial point, and then they go on forever in one direction. So let's go ahead and draw a ray. I'm going to call this ray, here we go. In this case, B is my initial point. Rays are named with two capital letters. The initial point must come first. And the symbol, which is a little baby ray, goes on top of the letters and always points to the right. So if I was to name this ray, I would have to start with B, because that's the initial point, then A, and put the little baby ray symbol pointing to the right. If I had this ray, I would start with C because that's the initial point, then it's going through D, and I put the little baby ray symbol on top. No matter which way your ray points in the diagram, the symbol on top of the name is always going to the right. Oh, I forgot to highlight the word initial point. I know you guys don't want to skip an important vocabulary word. All right, so be careful. In this example, KJ and KL are called opposite rays because they form a straight line. Opposite rays have to have the same initial point. Okay, so I'm starting at K, and then going on forever. So same initial point. Opposite rays are important, and we're going to be using them a lot this year. Ray JK and KL, however, are not the same rays because they have different initial points. I can, however, say that ray JK and ray JL are the same ray. They have the same initial point, and they go on forever in the same direction. It's just a matter of which letter I picked along the ray for the name. Line segment, and we often just call it a segment. No particular reason other than it's easier. A line segment is part of a line, and they have two endpoints. Segments are named with both endpoints and a little baby line segment symbol on top. So MN, I would name it segment MN. Again, you always read the symbol on top, so I would read the bar first, which is segment, and then the letters MN. I could also name this segment NM. Congruent segments. Congruent segments, when we mark them in diagrams, they use tick marks. Now, congruent segments are exactly the same. They're the same structure, the same size, the same shape. We use our congruent symbol, the equal to sign with the tilde on top. And these two segments are congruent, so I would mark them with a tick mark in a diagram. If I named them AB and CD, I would say segment AB is congruent to segment CD. If you have more than one congruent segment, you use more than one tick mark. Okay, so those two are congruent. These two are congruent. You can have triples, quadruples, but please break out the colors if you have more than 4 tick marks on anything. Next up, we have a plane. A plane is a flat surface made up of points. Everything we've talked about today is made up of points. Plane extends infinitely in all directions, and I'm going to say it's two-dimensional. No depth. Okay, it's flat. So it's got length and width, and it technically goes on and on and on forever. The problem is we have no way to represent that on a piece of paper. When we draw it, we usually end up using a parallelogram shape, which makes it look like it fits inside that box. It doesn't. It goes forever and ever and ever. We just don't have any way to show that on a piece of paper. We name a plane with any 3 non-collinear points. So A, B, C, and I have to use the word plane. A, B, C. Or an uppercase cursive letter that's not attached to a point. Okay, so I could call this one plane R. It's hard to do cursive, at least for me, just randomly up here on the board. I generally go with 3 points on the plane. Coplanar points are points on the same plane. So let's draw a plane here. A, B, C. We could say points A, B, and C are coplanar. Non-coplanar points are points that are not on the same plane. So I could say points B and D are non-coplanar points. They are not on the same plane. The way I've drawn this, it looks like D is below the plane that has A, B, and C in it. Sometimes you see something like this. So I've got a plane with a line going through it. That line is not on the plane. I know that because of the dashed marks. The little dashed part of the line means that's hidden underneath my drawing of the plane. So think of your paper with your pencil stabbed through it. Okay, the point where your pencil intersects the plane is point A. A and E are collinear. E and B are non-coplanar. Lots of great vocabulary. Alrighty, so what do intersections look like? I was just talking about an intersection where where your pencil stabs through your paper. Two lines intersect in a point. You did this in Algebra 1, back when you did systems of linear equations, and you graphed them, and you found the point of intersection. Two planes, however, intersect in a line. And I gave you this drawing. We have plane L and plane M, and they intersect here in line K. Now remember, those planes are infinite, right? So where they intersect has to be something infinite, like a line. So let's try a couple of these. Use the diagram at the right to name the following 4 collinear points. I could have H, N, K, and I. H, N, K, and I are all on the same line. Name a line that contains point M. Well, here's M, so I'm talking about this line. Let's see, I could call it MN. I could call it MO. I could call it line NO. I could even call it line P. Options. Options are a great deal of fun. Name a ray that begins with point K. Well, here's point K. So I could go ray KI. Ray KJ. Ray KL. I could even say ray KN, or I could call that ray KH. Either name for that last one. Oh my, I've made quite a mess of my diagram. I'm going to erase it real quick. Oops. Why didn't I get the eraser? There we go. Okay. Name a line that contains points H and K. Well, the easiest way to do that is just say HK with a line symbol on top. I had two capitals. But looking at my diagram, I'm talking about this line. I could call it line R. I could call it line HN. I could call it line KN. I could call it line IH. There's more, but I'm done. You only had to name one, and there's quite a bit there. Another name for line Q. So here's line Q. Okay, pick two letters on that line. Line JK, or line JL, or line KL. Any one of those answers would be fine. The intersection of lines P and R. Well, R is already up there in red. P is this line here, so it intersects at point N. A line segment on line P. P's in green. That could be segment MN, segment NO, or segment MO. Any one of those three answers would be fine. I want you to try the next one on your own, so pause the video and then pick back up after you've written down your answers so you can check your work. Alrighty, check your work. You only had to come up with one answer for each of these. So in A and B and C, you didn't have to list all of them. In C, I couldn't list all of them. We had to pick, if we didn't choose plain M, with that being the cursive letter up there, we had to pick three non-collinear points. So ADE, AEF, ADF, it just gets to be too much to list. Try the next set, pause your video. All right, check your work. This one is interesting. There were a lot of answers for letters A and B. I certainly couldn't name them all. But when I look at this diagram, what I see is a square pyramid sitting right on top of plane R. So I see plane R as one plane, and then each of the four triangles as a separate plane for 5 planes altogether. It's a tricky one. Okay, remember, planes extend infinitely, so the intersection of two planes is going to be a line. It might look like a line segment, but two planes intersect in a line. All right, take a minute to answer the questions on this page. All righty, so this is a very interesting diagram because what we have going on are parallel planes. Planes P and Q are parallel to each other. Think of the top of your desk and the floor of the classroom. They're parallel to each other. And then we've stuck a really, really long straw through both of them, and that would be line L. I sketched for the next one 2 parallel lines, making sure to mark them as parallel with the red carets. For the next one, I drew parallel planes a different way. Okay, this one definitely top and bottom kind of picture, like your desk and the floor. 2 planes that intersect are always difficult for me to draw, and my drawings are never very good. But in this case, I drew perpendicular planes. Okay, and in theory, those are intersecting at a right angle to each other. Oops. All right, last question here. We want to look at the diagram and decide if this is true or false. Is line A parallel to line B? So here's A, here's B. I don't see any carets at all, so false. Is segment UT right here congruent to segment SR right here? And yep, they both have 2 tick marks. So true. Is segment UT perpendicular to line B? I don't see the little box, so false. Is segment TR, goodness, that's not even drawn, congruent to segment US, which isn't even drawn? Well, no. It's not drawn, it's not marked, it can't possibly be congruent to each other. So what I want you to do now is I want you to write a summary of what you learned in this lesson. What is the most important thing to take away from the lesson today? What do you absolutely need to remember?